This is Lecture 1, Review of Theory Building. By the end of this lecture, you should be able to explain how to apply the scientific method to political science research, explain the differences between an independent variable and a dependent variable, develop a theory that includes an independent variable and a dependent variable, derive a hypothesis from a theory, graph the relationship between two variables, and understand the role of evidence in the scientific process. This semester, you are taking an advanced research methods class in political science. Before we talk about these methods, we first have to discuss the scope and goals of political science itself. So what is political science? Political science is the study of politics in a scientific manner. Politics deals with any outcome that is related to public decision making. These outcomes could include many topics, such as voting behavior, the legislative process, or interstate war. Political scientists use the scientific method to describe these political outcomes and explain why these outcomes occur. There are 5 steps in the scientific process. You will be following these steps in your research project this semester. The first step is to identify a dependent variable. A dependent variable in this case is a political outcome of interest in a paper. Our goal is to explain why variations in that outcome occur. For example, imagine you are interested in studying variations in democracy levels in countries throughout the world. You would want to explain why some countries have higher democracy levels than other countries do. Note that we are not interested in explaining why specific outcomes occur. Instead, we are interested in explaining why many different outcomes occur across many different cases. In the democracy example, we did not want to explain why one specific country, like the United States, was a democracy. We wanted to explain why many different countries were democracies while others were not democracies. In other words, what we are really interested in is explaining the variance in the dependent variable. We want to examine many different levels of the dependent variable. The second step in the scientific process is building a theory to explain why we see variations in our dependent variable. In this theory, we usually choose one independent variable that we believe influences variation in the dependent variable. We believe that variations in the independent variable influence variations in the dependent variable. In other words, changes in the independent variable come first and then cause changes in the dependent variable. In our theories, we have to be specific about how we think the independent variable influences the dependent variable. We state that the independent variable has a positive effect on the dependent variable or a negative effect on the dependent variable. If we believe the independent variable has a positive effect, we believe that as the independent variable increases, the dependent variable increases. If we believe the independent variable has a negative effect, we believe that as the independent variable increases, then the dependent variable decreases. We must also explain why we think the independent variable should influence the dependent variable in the way we expect. It could take several pages of text to explain why the independent variable influences the dependent variable that way. You have to be very specific about the process in which the independent variable influences the dependent variable. Explaining why an independent variable influences a dependent variable is a writing skill that you will develop in this class, but will develop much further in your other upper division political science classes. As an example of theory building, imagine our dependent variable was democracy level and our independent variable was oil wealth. We could expect that changes in oil wealth lead to changes in democracy level. More specifically, we could expect that as the oil wealth of a country increases, the country's democracy level should decrease. This tells us how the independent variable influences the dependent variable. As to why we expect this relationship, we could make the following argument. Leaders of non-oil rich countries rely on citizens' tax revenues to run the government. In exchange for taxes, citizens demand power over government decision-making, which leads to democratization. In contrast, leaders of oil-rich countries rely on oil revenues to run the government, not citizens' tax revenues. so citizens have less incentive to demand power over government decision making. Of course, this argument is quite short and should be expanded on to explain how oil wealth influences democracy level in more detail. The third step in the scientific process is deriving a hypothesis from your theory. A hypothesis is a one-sentence statement that describes how all of the variations in the independent variable influence all the variations in the dependent variable. If the independent variable has a positive effect, then as the independent variable increases, the dependent variable should also increase. And if the independent variable has a negative effect, then as the independent variable increases, the dependent variable should decrease. In addition, the relationship described in the hypothesis has to be observable in the real world. We should be able to collect data and determine if the independent variable influences the dependent variable in the way we expect. There are several different ways to write hypotheses. In the next few slides, I will provide you with some templates on how to write hypotheses. This is the more likely than / less likely than template. This template is useful when you have an independent variable and a dependent variable that are dichotomous. Dichotomous just means that a variable only takes on two categories or values. For example, imagine your dependent variable was party identification. It only takes on two categories, Republican and Democrat, and your independent variable is gender, which also only has two categories, women and men. You could write, women are more likely than men to identify as Democrats. Note that this hypothesis identifies how variations in the independent variable, gender, or women/men, influence variations in the dependent variable, party identification, or identifying as Democrats versus Republicans. In addition, we can observe this potential relationship between party identification and gender in the real world. We could conduct a survey where we ask respondents their party identification and their gender, and then determine if women are more likely than men to identify as Democrats. The next hypothesis template is the more than / less than template. This template is useful when you have a dependent variable that is continuous, as in it takes on more than two values and has inherent order, and an independent variable that is dichotomous. For example, imagine your dependent variable is defense spending, which is continuous as it can take on any positive dollar value, and your independent variable is type of institutions, which only takes on two categories, whether a country is a democracy or a dictatorship. Our hypothesis could be dictatorships allocate more resources to defense spending than democracies do. Note that this hypothesis identifies how variations in the independent variable, democracy/dictatorship, influence variations in the dependent variable, defense spending. In addition, we can observe this potential relationship between democracy/dictatorship and defense spending in the real world. We could collect data from public records on countries' defense spending and collect data on whether countries are democracies or dictatorships. Then we could determine if dictatorships spend more in defense than democracies do. The last template is useful when we have an independent variable and a dependent variable that are both continuous and take on multiple values, or more than two values. It is the independent variable increases, dependent variable increases/decreases template. For example, imagine our independent variable is the per capita income of a country and our dependent variable is defense spending of a country. Both variables are continuous as they take on more than two values and the values have inherent order. Our hypothesis could be as the per capita income of a country increases, the amount of resources the government spends on defense increases. Note that this hypothesis identifies how variations in the independent variable per capita income influence variations in the dependent variable defense spending. In addition, we can observe this potential relationship between per capita income and defense spending in the real world. We could collect data from public records on countries' defense spending and collect data from public records on per capita income in those countries. Then we can observe whether countries' per capita income increases their defense spending. This metacognition card can help you decide which hypothesis template to use based on which kinds of variables you have. If you have dichotomous independent and dependent variables, use the more likely than less likely than template. If you have a dichotomous independent variable and a continuous dependent variable, use the more than / less than template. If you have continuous independent and dependent variables, use the independent variable increases, dependent variable increases / decreases template. It is easy to make mistakes in hypothesis writing. A common mistake is not correctly identifying what the independent variable is. For example, you could say some countries are more likely to go to war than others. But which countries exactly? What specifically leads some countries to be more war prone than others? Another mistake is not focusing on how variations in the independent variable influence variations in the dependent variable. You could say wealthy countries have high standards of living, but you're not comparing wealthy countries to anything. High standards of living compared to what? Instead, you should say that wealthy countries have higher standards of living than poor countries do. This is a comparison where you are comparing how variations in the independent variable wealthy/poor influence variations in the dependent variable standards of living. If you are having problems determining whether you wrote an appropriate hypothesis based on your theory, you could draw a graph based on your theory/hypothesis to see if it is an appropriate hypothesis. On the y-axis, you would place your dependent variable, and on the x-axis, you would put the independent variable. You should label the appropriate values on the axes and then draw the hypothetical relationship between your variables based on your hypothesis. For example, imagine your hypothesis was, as the per capita income of a country increases, the amount of resources the government spends on defense increases. This is what the graph would look like based on this hypothesis. Defense spending is the dependent variable, so it's on the y-axis. Per capita income is the independent variable, so it's on the x-axis. And as per capita income increases, defense spending should increase, resulting in this line with a positive slope. The fourth step in the scientific process is the empirical analysis. In this step, we collect data for the dependent and independent variables and then analyze the statistical relationship between the independent and dependent variables. In this class, we will focus on large and empirical analyses, where we collect a large number of observations across many cases to analyze the relationship between our independent and dependent variables. There's another type of a design called a small n design, where scholars only focus on a small number of cases to analyze the relationship between the independent and dependent variables. We will not focus on small n designs in this course. Note that n in both of these cases just means the number of observations. In the fifth step of the scientific process, we evaluate our theory, our hypotheses, and our empirical results. We determine if the results of our empirical analysis provide support for our hypotheses or indicate lack of support. In this step, it is important to note that we should not overvalue our evidence. Just because you find results in one study, those results need to hold up in other studies for us to be more confident that our independent variable actually does have an impact on our dependent variable. Also, just because we don't find results that support our hypothesis doesn't mean our hypothesis is wrong. There are many reasons, many statistical, that may lead to no results. We will be spending the second part of the semester talking about these issues and how to address them. You will learn to make more sophisticated statistical models to test your hypotheses.